Today we will look at impulse. We have already studied impulse. We will just do a recap. So, impulse is when an external force acts on an object for a very short time and changes the object's motion. This is called impulse, the definition. The examples: kicking a ball, catching a ball, collision between two objects. What is the impulse equation? It is force multiplied the time it acts for. And impulse of a resultant force is equal to the change in momentum of the object because the force stops the object. So F into T. Ignore this sign for because we don't really use this sign, but it just should be there. It is the change in the time, but we just use the time. Change in momentum. This time we use this sign because it is the change sign, the operator sign, the delta, the change sign, change in momentum. So impulse is equal to change in momentum. Change in momentum can be described as we have also done this. This is the proof of this thing. So change in momentum is equal to mass times velocity, momentum, mass times velocity, final velocity minus initial velocity, and this final velocity minus initial velocity gives us the change in momentum. So impulse or change in momentum are the same thing, so they are equal. We will use this in our numericals. So we look at question number 5. Question number 5 says the force 5 Newton applied to a cricket ball for this much time. So we have force F, we have time T, we can calculate the impulse using this formula. Change in momentum, well, the impulse and change in momentum are the same thing. So we will just do the same thing for the second part. So we'll just write the answer of the first part in the second part. So, question number 6, in a collision, a car whose mass is 1000 kg traveling at this velocity comes to rest in this much time. So, 3 data information is given. So, we will use this to calculate. We will use this to calculate the change in momentum. The change in momentum of the car can be calculated by considering that it comes to rest from a velocity v. So we have mass, we have velocity, that is the initial momentum, and the final momentum becomes zero because it comes to rest. So final momentum and initial momentum gives us the change in momentum. And then we have the force that is applied to the car to stop it. So this second part I will show you. All the remaining, so this part you will do yourself, this part you will do yourself, this part you can do it yourself. I will show you how to do the second part. So what force you need? So just consider this formula. If we bring T as denominator of P, that gives us the force. So we have the change in momentum and we have the time for which it acts. So change in momentum is 1000 times 24 minus 0 and divided by the time, which is 1.2 seconds. So look at this, how it is done here. So this is the mass and this is divided by 1/2 and that gives us this. This is the force. I hope it is very clear. So please complete all these questions. Thank you.